Good morning, everyone. My name's Argon. I'm the head of SOLTRAK. Thank you all for being here. This is the first of hopefully many webinar series that we would be hosting as SOLTRAK. And today I'm going to be focusing on the importance of solar performance monitoring. For those of you who might not have come across SOLTRAK in the past, so SOLTRAK is a performance monitoring and analytics platform. We service over 200 assets in the CNI sector, over 200 solar PV assets. We provide a live platform for monitoring, but we also do monthly and annual reports. So kind of a very relevant topic to us, and I'll just be taking you through why monitoring is important. So without further ado, I'm going to share my screen. Just a quick note on some house rules. So there is a chat that is available to you if you have any questions. I do have Nicole, our comms, on comms, that is going to be just looking at the questions, and towards the end I'll try to answer some of the questions. We also will try to keep it interactive, so there will be polls that will pop up on the left of your screen as I go through the presentation. We will also maybe look at some of the results of the polls after you've had a chance to provide an answer to those. Okay, so I believe my screen is being shared. Great, so starting off firstly, so looking at solar PV as an asset that is a long-term investment. So typically how solar PV is funded is still through capital outlay, although we do also see PPA structures. A lot of assets will still be on a capital outlay, so you're putting in capital and you're hoping to earn a return on that investment. Typically you would be looking at a return of anything between 10 to 20% on that investment. But what's important to note from a monitoring and maintenance perspective is that especially in the early life of the asset, underperformance and mismanagement or poor maintenance can compound over time and significantly affect the return on your asset. So it's quite important from a very early stage of the lifetime of the asset to ensure that you have strong monitoring and maintenance protocols. So on the right of the screen here, I've got an illustrative example of a real asset where we've projected the cash flow of this asset for its lifetime, and then in the orange we've got that same asset, but underperformance factor being applied to that of 5% and getting worse over time. As you can see that from the graph, it's an exponential effect. So whilst it might not seem, in the first few years, it might not seem as much of an issue. When you look at the long-term returns of the asset, it does become quite significant. Yeah, so just as I mentioned, so poor maintenance doesn't have a linear effect. It accelerates as the asset degrades due to poor maintenance. So any small delays, any poor maintenance or lack of attention given to the asset can compound into issues such as hotspots and thermal stress on the panels, inverter replacement cycle shortening, so needing to replace your inverters much sooner than you might have originally modeled for, and then also significant downtimes where you are losing out on the energy cost savings that you've modeled into your financial model. So long-term performance is not necessarily only about uptime, but we're also trying to preserve the equipment, so preserve the modular efficiency and the electrical integrity of the system. So we've established that maintenance is important. The next thing for us to look at is how would we bring maintenance onto the site. So there are typically two types of structures. You can either go for an ad hoc approach, which means that you as the asset owner or asset manager is contracting out for work needed on site on a per need basis. Basically, you would identify that there's an issue on the site, and then you would contract, for example, someone to go clean the site, or to do minor electrical works on the site, or to do an inspection on the site. Importantly, in this kind of structure, it tends to be quite reactive, and there wouldn't be a guarantee or accountability because you wouldn't have a long-term service provider dedicated to the site. On the other hand, it can be more cost-effective depending on how much attention the site needs, and whether, for example, you have someone in your team that is able to monitor and has the expertise to be able to monitor. The other main and much more common maintenance structure that we see in the industry is a contract-based structure. So this is more predictable because what you're able to do over the length of that contract term is essentially ensure that your asset is going to have the care that it needs. It's going to be maintained based on the expertise of an engineering expert or a solar engineer expert, typically an EPC or an O&M company that would action inspections, cleans as per the site's needs. And they can also implement preventative measures. So they would be doing monitoring on their side to ensure that the asset is performing as it should, and if there are risks, that those risks are being mitigated. Often underlying a contract-based structure would be the O&M contract, and in that contract, there are certain things that you should have in that contract to ensure that you're going to get a good O&M service. So the first thing is a clearly defined scope of works that outlines the activities to be conducted during the inspections and the cleans. Basically, you want to make sure that when people are going out to site, that they're actually checking everything they need to check, and that there is some record being kept that they have checked those items. Next is response times based on severity of the production risk. So what you need to include is, in the event of a production risk, such as, for example, inverter failure, there needs to be a clear indication of how much time the service provider would have to pick that up, but then also to action someone going out to site, or in the event of a warranty needing to be enforced, for the communications to be sent out for that replacement. So it's quite important to have a clearly defined response times, and then often if a response time, so if the service provider doesn't respond in time, they would then start to become liable. For example, if in the scenario where equipment fails and it can be proven that it is not the fault of the service provider, but the service provider has not identified and actioned the replacement, or notify the client of a replacement needing to be done, then they can then be held accountable for that, or for that lost energy during that time. So thirdly, a guarantee mechanism. So there are quite a few different guarantee mechanisms in the industry. The main ones are fixed energy output, quite straightforward. The service provider basically indicates that the system will produce a minimum energy output within a specific year. Then we have weather adjusted. So weather adjusted mechanisms. A very common one is performance ratio. It's different to fixed energy output because this guarantee would vary based on the irradiance in a given month or over a given annual period. So if, for example, the irradiance was less for a given month, the guaranteed energy would be less. And basically a metric like performance ratio is taking that into account. And then lastly is availability or uptime. So all the service provider is guaranteeing there is that the plant will be available or will be online during for a certain percentage of a month or a year. They're not necessarily giving you a guarantee on how much the plant will produce. Lastly, it's also quite important to, when it comes to monitoring and measurement, to have clarity on what the primary data sources are going to be used in measurement. So, for example, for production, are you using specific meters? Are you using an inverter summation? It's quite important that the service provider and yourselves are on the same page of what the ground source of truthful measurement will be. Typically, we would use billing grade meters on most CNI plants. And then lastly, a methodology for quantifying deemed events. This is quite a big one. So a deemed event is any event that results in a loss of production that the service provider should not be held accountable for. So common examples of this would be something like load shedding or low load curtailment. And it's quite important that how this is quantified is quite clear based on the contract, because in the event that the service provider doesn't meet their guarantee, it's important to understand the impact of these deemed events, which would be accounted for against the deficit or surplus, to ensure that kind of a fair penalty is reached in that evaluation. Just some general notes on some industry trends around guarantees. So what we found is that a lot of the simulation, the weather models in quite commonly used simulations in the industry have been, there's been some inaccuracies or not inaccuracies, they just haven't been very good predictors of actual weather in the past few years. And as a result, the fixed energy output guarantee has come under quite a bit of pressure. A lot of service providers are moving away from a fixed energy output and moving more towards performance ratio or weather adjusted guarantees, which still hold the service provider accountable for not maintaining the site. It just does not hold them as accountable for lower than expected irradiance, which is out of their control. Then when it comes to sites that are in their second or third contract, so let's say you have had an EPC install a site, they've given you a 1-year EPC contract, that 1 year lapses, you get maybe an extension for 3 years, then that contract lapses and now you're in your essentially third maintenance contract. There's a potential that service provider stays on or another service provider needs to come in. And what we find is quite common on those second or third contracts is an availability guarantee. It's very common for service providers that are taking on sites that they themselves did not install. Obviously, they don't want to take on too much risk based on procedures that they might not have had line of sight of in construction or kind of quality of work in construction. Even though they would typically do a remediation assessment, often they do just prefer to go for an availability guarantee for older assets. So those are typically your two options. It's largely kind of choosing between largely depends on kind of a few factors like your budget, your focus, the internal capacity of your team, but contract-based structures are the most common. Okay, now looking at the key causes of underperformance. So we can kind of sort of break it down into this diagram. So you've got your DC issues and issues affecting your panel. So you've got soiling, string issues, optimizer issues, shading, or incorrect mapping of the string. So those are largely your DC side issues. Then you could also have AC issues or AC side issues. So the thermal derating of the inverters. You could have surges and breaker failures or comms issues. So yeah, where there's a loss of communications between the inverters and the cloud platform that the data is pulling into, whether that's the inverter platform or a third-party aggregator platform like Meteor Control. Then there could be also issues with the load itself, so lower than expected load, or essentially not enough load to utilize all of the generated energy, which results in curtailment. And then lastly, grid unavailability and grid surges, etc. So grid unavailability, the most common example in what we see is load shedding. So yeah, so this is kind of the rough summary of the main issues based, kind of broken down on a diagram perspective. What we now need to consider is, from a monitoring perspective, how do we identify these issues, or how can we best identify these issues without necessarily needing to send someone to site? How do we kind of identify the issue and then send someone to site so that we can also save money on call-out fees, which can tend to become quite costly once you've exceeded, in an O&M contract, for example, you'd have 4 inspections in a year or 4 cleans in a year. Okay, so there's, as I've mentioned, so there's multiple factors that can affect your performance. We've broken it down here. So this is an example coming out of our SOLTRAK reports, where we're showing the simultaneous effect of underperformance across a number of different factors. It's quite important to show and differentiate between the different impacts, because, for example, you could have a very good or very bad weather month, but the site is performing quite well, and you then know, okay, the service provider is actually doing their job. It was just a very poor solar irradiance month. But also helps you identify the root causes so that you know where to prioritize your interventions and what to focus on. And yeah, so what we're really getting at here is the kind of the power of data-driven diagnostics to help target issues and prioritize interventions and reduce unnecessary site visits. So yeah, so going from here, I'm going to kind of touch on each of these underperformance impacts and how you could potentially identify and what to look for in monitoring. Okay, so starting with production. So the main thing to consider with production is that you have different data sources. So you could have meters and you would have the inverters, both kind of speaking to production. Important to consider in terms from the metering side is if there are RX factors or scaling factors on those meters, that those are correct, but also that the meters are actually available. So you could have scenarios where the meter data is unavailable or unreliable, and hence you then need to default to a secondary data source, which could, for example, be the inverters. On the same side, you could have the inverters that lose comms, and you would need to revert to, you would essentially at least have the meter data as your primary data source. So in terms of how do we identify, or what can we use to identify at a very kind of from a desktop monitoring level when there might be an issue on the site? So a very good metric to use is performance ratio. And basically this is a ratio of what you expected to be produced by the site based on its capacity versus what could have been produced. So what was actually produced by the site versus what you expect the site to be produced based on its capacity and the irradiance for that month. So there's that inbuilt adjustment for the irradiance in the month. And you would typically expect for a new site performance ratios to be in and around 75%, and then degrading by around 0.6% per year as the years go on. So that's kind of a good indicator of the health of the system. So over here you can see that the inverter performance ratios are actually reasonably low. So they're sitting around the below 50%. So we know that there's likely something that needs to be investigated with regards to production on the site. So we would typically ask, okay, when is the next inspection needed to be done on the site, or when was the last inspection done on the site, and understand, go to those inspection reports to see if there's any information that we can gather there. But this is basically telling us that there is likely an issue on these inverters. Another thing that you can look at is inverter heat maps. So an inverter heat map is basically showing you so it's using the ratio of so per inverter, it's giving you an indicator of whether the output is what it should be or what is it expected, and it also helps to identify outliers. So for example, on this heat map, you're seeing this vertical line, which is indicating that there was no energy produced by any of the inverters during that specific 5 or 10 minute slot. That could be a comms issue. It could also have been a grid unavailability event that resulted in no production. So kind of you can gather some insight from a vertical strip like that. A horizontal strip would essentially mean that specific inverter was down. And you could kind of differentiate between that inverter being down versus other inverters being down. You can also start to identify kind of impacts if you look at this heat map from day to day and month to month to understand if there is a degradation. So, for example, thermal degradation in the inverters over time. If you have access to the inverter temperatures, that's also a good thing to look at. Okay, so then going on to the next one. So as I mentioned, deemed energy events such as curtailment and grid unavailability. So it's quite important. So there's two things that are quite important on deemed energy events. The first thing is identifying when they have occurred and having a mechanism for recording when they have occurred as they occur. So a really good way to do that is through a ticketing system. And then the second element that is quite important is quantifying how much energy was deemed to be lost. So there are a number of different ways of quantifying, but the most simple is to use the linear relationship between irradiance and plant production. So there's a linear relationship there that can be used. So for example, if in a given hour you have identified that the plant was down due to load shedding, you could use that relationship to determine the amount of energy that should have hypothetically been produced, because you would have an irradiance measurement. Sometimes you might not have an irradiance measurement, which is why we would often recommend that an asset manager has access to satellite data for the location of their site, because having access to the irradiance data becomes quite important when trying to quantify deemed energy events. Okay, so going on to soiling. So there are two main ways of estimating soiling, or the soiling rate, without having to actually do a visual inspection on site. So the first way is to do a sensor versus satellite data comparison. So you have an on-site sensor that is assumed to be soiling directly proportionally to the panels on the site. And then you have independent satellite data that is not affected by that impact. And you can compare that over time and get a sense of if there's an increasing difference between those two measures. So for example, you can calculate performance ratio using the sensor data and performance ratio using the satellite data. And if that is diverging over time, you have an indicator of the soiling rate. Secondly, you can use a clean or reference sensor versus the soil sensor. So in this method, you would have a reference sensor on site that is being regularly cleaned, and then the soil sensor that is only being cleaned when the plant is being cleaned or the plant panels are being cleaned. And then essentially the comparison, again, a PR ratio calculation comparison between the two gives you an indication of the soiling rate. Soiling rate is quite an important thing, or can be quite a powerful thing to keep track of, because you can start to get a sense of when it becomes economically optimal to actually do a clean. So a clean comes at a cost. You would usually have a specific number of cleans within your maintenance contract. So it would be left to the service provider in most contracts to determine when a clean is needed, because they would be on the hook for underperformance and hence incentivized to clean when the site should be cleaned. But more generally, if you were paying a call-out fee per clean, or you were paying per clean above and beyond your contracted cleans, you could use a method like this to determine, based on the value of energy or value of cost savings that you're losing as a result of soiling versus the cost of a clean, when that tipping point is reached, and when it then makes sense to actually send someone out for a clean. Okay, so those are kind of touching on those main underperformance impacts that are highlighted, and some mechanisms in the monitoring that you can use to ensure that you're picking up issues. Something maybe to mention just on the production side is it makes a lot of sense for either the service provider or the asset manager to have alerts. So what we do in SOLTRAK is we would typically have instrumentation alerts. So if an inverter is down for 2 hours or 4 hours, we are immediately alerted, and the frequency of those alerts and the sensitivity of those alerts are calibrated to the level of production risk. And that's just another way of ensuring that when there is a production risk on site, that whoever is monitoring the site is aware of it as soon as possible and can start to move the correct forces towards intervention as needed. Okay, so just in summary then, so some O&M best practices. So the first would be to establish an asset management plan or contract. As I mentioned, this could be ad hoc monitoring and sending contractors out, or it could be a specific O&M contract where you've defined the maintenance schedules, the site activities, responsibilities, and escalation protocols. So basically knowing how the site is going to be managed and who's responsible. The next would be implementing remote monitoring with automated alerts. So this is allowing you to enable real-time fault detection and minimize reliance on reactive maintenance. So using data to preventatively reduce the impact of underperformance effects. The next would be using performance analytics to detect underperformance early. So again, as I mentioned, and I've just gone through some of the metrics that we can use from a monitoring perspective to identify the impact of certain whether there has been a fault or whether there is soiling taking place. Next is maintaining critical spare parts inventory. So if on a specific site you've identified high risk instrumentation, if you know that it's going to take a long time to get a certain inverter or breaker, it can sometimes make sense to keep critical spares. So that is again a cost benefit analysis of kind of understanding what the financial implication would be of a lead time versus investing in the critical spares. And then lastly, optimizing cleaning schedules using soiling rate data. So what a lot of service providers will do is they will either clean when they've identified a clean needs to take place, so when they've identified that the site seems to be soiling, or they'll have a schedule based on season. So in the wet season, they'll maybe have 3 out of the 4 cleans, and then they'll only have 1 clean within the dry, dusty season. So what's important is that there is a cleaning schedule and there is a methodology around identifying cleans, and also ensuring that the site is being cleaned only when it needs to be cleaned. So yeah, so that is kind of the summary of kind of best practices, and hopefully through the brief kind of description of kind of the role that monitoring can play and how monitoring can be leveraged to preserve the long-term prospects of your asset through a data-driven approach. Hopefully that has come through. That is the key takeaway, that data can be a powerful tool in operation and maintenance when it comes to solar plants, and companies like ourselves, like SOLTRAK, are well placed to implement those monitoring practices. So I'm going to have a look now at just some of the results in the polls, and if there were any questions that came up. So, okay, let's start with the first poll. Do you think guarantees are an effective and fair O&M contract mechanism? The result was mostly yes, and it depends. So from that, I gather that everyone understands or agrees that sites do need to be maintained, and that the "it depends" is largely stemming to the specific scenario. So what can sometimes happen in the industry is that the guarantee is used as a kind of a stick approach. And what is not accounted for in a very guarantee-heavy approach is that, for example, if a service provider, if there's poor maintenance in a given year, and the service provider is then held liable to a guarantee and a penalty, and then steps away in the next year, the impact of that underperformance or poor maintenance, as I mentioned, is exponential and has potentially long-term ramifications, which the client actually does not have the power to retrieve. They can only retrieve the penalty for that year. If there is long-term damage done to the site, they actually don't have a mechanism to retrieve that lost value. So that's why we also sometimes see that the guarantees will be linked with something like an incentive. Is something that we're starting to see in the industry. So beyond just using kind of a stick approach, saying yes, there'll be a kind of a minimum that you need to produce, but also if you produce above that, you could potentially take a percentage in that revenue saving. So we are seeing that in the industry as well. Okay. Which guarantee mechanism do you think is most common in today's C&I sector? So the majority said performance ratio, which I think overall is probably correct. I think it's maybe a little bit more even with fixed output and performance ratio, but the trend is definitely towards performance ratio. And that's just, as I mentioned, the EPC company is not necessarily an expert in predicting weather, and hence, as time has gone on and as the industry has matured, they're less willing to take on that weather risk, and hence performance ratio is becoming a lot more common. In the projects you have been involved in, has deemed energy quantification come up, and was the methodology clear? Okay, so the majority said yes, which is actually quite surprising. And a lot of the experience that we've had with representing clients in front of O&M service providers is that whilst deemed energy comes up as a line item, as a final line item, or is highlighted within a monthly and annual report, the quantification method isn't necessarily always clear and made clear in the O&M contract. So yeah, I think there's still a lot of education in the industry on the importance of that, and the importance of that in empowering the client to be on level footing when it comes to understanding the performance of the site, and also, if it comes to it, the quantification of the deficit and the penalty. Okay. Are cleans on your sites guided by a fixed schedule, visual inspection, or analytics? Yeah, so most people said fixed schedule. So yeah, I think this is quite typical of most O&M companies and EPC O&M companies, is they will include a certain number of cleans within that contract. So for example, a quarterly clean. And yeah, so they're basically just cleaning per quarter. There is a risk in that, and I think some EPCs are trying to mitigate that risk in doing more cleans in the wet season versus the summer season or the dry season. But this is where you start to see how ad hoc service provision can be more attractive, because if a site did not need to be cleaned at all in that year, you've paid for 4 cleans that might not necessarily have been needed, although it's likely that the site would have been needed to be cleaned at least once. And so if there's this fixed schedule but the works actually isn't needed, then you are paying upfront for something that you end up not utilizing. But yeah, ultimately, that can also be negotiated in a contract, and a lot of contracts do also have just the cleaning fee and call-out fee as kind of line items that can be added based on the need. Okay, so those were the polls. In terms of questions, should maximum demand savings be taken into account when considering underperformance of a kilowatt-hour guarantee? Yeah, so typically demand savings and any other, we can almost think of it as an ancillary benefit. We don't advise including that when it comes to the underperformance, kind of evaluating the energy performance of the site. It can be something that is accounted for, or it is something that would be accounted for in terms of the financial performance of the asset. So quite important to track that and to make sure that your system is taking full advantage of that, or has been designed to take full advantage of that. So I would say it's considered within the financial performance, but when it comes to the energy performance, so whether the site is performing as it should be, it's probably best to stick to the kilowatt hour impact. So the kilowatt hours produced versus what was guaranteed, and then essentially you're using the blended rate to understand what the value of that surplus or deficit was. We have had scenarios in the past where service providers have asked to have certain ancillary benefits offset if they, for example, if there was a penalty and the service provider has provided an ancillary benefit that has resulted in more value than was initially foreseeable in the original modeling of the site, that they have then asked for that to offset the penalty. At the end of the day, that is largely up to the client's discretion, and yeah, it's not necessary. I don't think it's something that should necessarily be done. I think all of those aspects should be agreed upon upfront when the site is delivered. Yeah, so those were the questions and the polls. This is just the first of hopefully many webinars like this. We'd like to start to do in the upcoming sessions, we'd like to do deeper dives into things like cleaning and soiling and kind of various other performance analytics specific aspects that we're seeing developments in the industry from the SOLTRAK perspective, and we're seeing kind of an importance for asset managers to know as well. Great, yeah. So in terms of sharing this presentation, I think we can share a copy of the presentation, and then also if you would like to ask some questions or get to know more or explore the SOLTRAK service, there's also an email address here that you can contact us through, and yeah, so as I mentioned, SOLTRAK, we're currently providing a service to over 200 assets where we are doing the performance monitoring using some of the practices that we've highlighted in this webinar, as well as monthly and annual performance reports. Yeah, so that's all for today. I think I've been very efficient, so we've ended a little bit sooner than expected. But thank you all for attending, and we hope to see you at the next one as well. Thanks, everyone.